In this paper, we propose a scene region classification approach for visual localization with only few shot images as database. Visual localization is a key component of many applications such as augmented reality and navigation. Specifically, given a database of posed images and single query images, the task is to estimate the camera pose of each query image. Recent advances solve this problem by memorizing the mapping from image pixels to scene coordinates. A common way is to encode the aforementioned mapping as parameters in a neural network. Then for a query image, the network predicts 2D to 3D correspondences between the image pixels and the scene coordinates. Using these correspondences, the camera pose is solved by geometric optimization. Although achieving high accuracy, these approaches require amounts of posed images to train their models in each scene, therefore can hardly be deployed in practice. On the contrary, few shot images are usually sufficient to cover a scene for human operators to memorize the scene. One hypothesis is that we humans have learned during daily life the prior knowledge to extract visual features, and only have to memorize the locations of features in a novel scene. Incorporating these insights, we study fast scene memorization with only few shot posed images as training data. To involve pre-learned knowledge, we decouple the scene coordinate regression pipeline into a feature extractor followed by a coordinate estimator. The feature extractor aims to extract robust visual descriptors across different scenes, therefore can be pre-trained as prior knowledge. And the coordinate estimator aims to memorize the locations of visual descriptors in each scene. Recently, learning-based descriptors achieve promising feature embedding under viewpoint changes and across different scenes. Therefore, we make use of pre-trained superpoint as our feature extractor to obtain semi-dense features from an input image. Then, the coordinate estimator takes the features as input and outputs semi-dense coordinate estimations. Instead of regression, we discretize the scene coordinates into regions and introduce a hierarchical classification approach to achieve fast memorization. Specifically, we run the k-means algorithm on the few-shot scene coordinates, to obtain M clusters as the first level of region partition. By iteratively partitioning each cluster, we eventually obtain a n-level M-way tree. Each level of the tree corresponds to a classification network that solves a M-class classification task. At the first level, the feature maps are fed to a CNN to extract scene-specific feature patterns, which are followed by a pixel-wise MLP to output the classification probability. Starting from the second level, the feature patterns are modulated by a hypernetwork according to the classification probability from previous levels. We apply a meta-learning strategy to pre-train the hierarchical networks. The pre-training aims to find proper network parameters as initialization to perform fast training convergence in novel scenes. After the memorization, the network infers 2D-3D correspondences, and the camera pose is solved by geometric optimization. Before optimization, to limit the number of coordinates, we partition each leaf into Q clusters and utilize the cluster centers for optimization. The camera pose optimization is a variant of PNP-based ransack algorithm to handle one-to-many correspondences. And the 3D coordinates are adjusted during the optimization. We evaluate our method in both indoor and outdoor scenes. In the few-shot setting, all methods suffer performance drops, and our method achieves the best camera pose accuracy. Meanwhile, our method costs less training time to converge. In outdoor scenes, our method outperforms scene coordinate regression-based methods, but underperforms H-lock. Since H-lock doesn't require the rendered pseudo-ground truth depth for supervision. In the top and bottom rows, we visualize our estimation in red and ground truth in blue. In the middle row, we select the image with the median pose error in each scene and visualize the accuracy by overlaying the query image with a rendered image using the estimated pose and the ground truth 3D model. To conclude, we propose a novel problem setting that performs visual localization with only few shot posed images as database. A simple and effective method based on hierarchical scene region classification is proposed for fast scene mapping with low error. Experiments show de Tall soda visual localization methods suffer from a performance drop in the few shots setting. Improving the camera pose accuracy worth more explorations in future works. Thanks for your attention. Our code is publicly available on GitHub.